Okay, well, we're group number 5, and I'm Dawn.
And I'm Nancy.
I'm Kathy.
And I'm Connie, and our presentation is on stem cell, adult stem cells. What you see here in this picture is a picture of a stem cell. You'll see them throughout. They were so fascinating, I decided to add them to the presentation. Um, Kathy's going to start tonight.
And just to give you a historical background on adult stem cell, while our research was actually specifically kind of targeted towards adult stem cells, it was really hard not to delve into some of the other aspects of stem cell research. So we're going to kind of define all of them for you and let you know the differences between the types of research and the regulations and so forth. So the three basic types of stem cell research are adult stem cell, fetal stem cell, also known as umbilical cell stem cell, and then the embryonic stem cell research. And we have a timeline that kind of tells you where things started. In 1800, the discovery of cell biology and the microscope started, and with the beginning of the discovery of microscopes, the scientists first began to kind of look at what our bodies do and how our cells reproduce and how they differentiate, and figured out that they're the building blocks of life and that they are capable of giving rise to other cells. The first real adult stem cell happened kind of as an accident in the 1950s with radiation therapy and also with chemotherapy. They did bone marrow transplants, and they had tissue-specific stem cells back in the 50s, and that's when they started doing bone marrow transplants for people that had leukemia. Earlier in times, physicians would try to do stem cell regeneration by giving people stem cells by mouth, but it didn't work. And what they figured out with research with mice is that they could regenerate. And so that's when they started doing the chemotherapy treatment, or giving stem cells for chemotherapy. In 1978, was the time that fetal or umbilical stem cell research evolved. And this is the kind of stem cell that you can get from umbilical cord blood or from the placenta that's expelled after birth. And these are also from fetuses that have been terminated. And what it allows you to do is to be non-intrusive. It is a type of research, or stem cell research, that doesn't require anyone to be harmed. And then in 1998 was the first time that human embryos were used for stem cell research. And these were actually embryos that were grown in a laboratory. They were fetuses that people used for in vitro fertilization. Once they used however many embryos they wanted for reproduction, then they donated the embryos for scientific research. This is also, however, the most controversial type of research available with the stem cells.
Now I'll be discussing some of the information on research with adult stem cells. Adult stem cells, they found, are pluripotent, and what this means is that the cells are able to differentiate into other types of cells. For example, you can take adult stem cells from bone marrow and in a laboratory regenerate them into, say, white or red blood cells, so it can become a completely different cell. Initially, researchers thought that only the umbilical cord and the embryonic stem cells were pluripotent, so it was an important point when they found out that the adult stem cells were actually like this, which made them much more important in their research. While the umbilical cord and the embryonic stem cells are able to be transplanted into other people, the big advantage with adult stem cells is that the cells are harvested and then transplanted back into the same person. And this is called autologous transplant. So there's no way for, if you're using adult stem cells, for there to be any problem with tumors or for there to be rejection in the body, because the cells are coming from the actual the patient that's going to be receiving the new cells. There is a problem with rejections and tumors that have turned into cancers, which have come from using the stem cells that are from the umbilical cord or from the embryonic cells, because obviously they are coming from a different body type. Embryonic stem cells, they're able to be easily harvested. Obviously, because they're used from leftover cells, and then once they have them in the laboratory, they are real easy to be duplicated, and they can duplicate for up to a year. The adult stem cells are a lot harder. They're a lot harder to identify in the body, and there aren't that many cells. So for research purposes, when they are trying to harvest them, it is a bit more time-consuming to be able to do so. Also, adult stem cells can kind of intermingle in with other cells, so that also kind of makes it a little bit difficult to be able to locate them and harvest. Even though it is a harder process to actually harvest the adult stem cells, one thing that makes them superior to the embryonic or the umbilical cord cells is that the process isn't as controversial, and we'll be discussing the controversial information a little bit later. There's been a lot of research with stem cells in the last few years. Early in the 21st century, there was a doctor that took bone marrow and injected into a patient's cardiac muscle, and it regenerated cardiac muscle that had been damaged from a heart attack. They've also had research in the areas of Crohn's disease, which is an intestinal disease, in thalassemia, which is a blood disease, and then some rare skin diseases. Currently, they're doing research with genetic and acquired disease, which of course affects the blood and the bone marrow. And then moving into the future, there's being research that they're looking into to find the origins of a lot of diseases, including stroke and cardiovascular disease. And scientists are using chemical markers now to track the adult stem cells in the body, so as they replicate in the body and they become different cells, they can kind of track them to be able to harvest them a bit easier. And then the last thing that they're doing is they're starting to study patients that have certain diseases, and they're comparing them with the adult stem cells of healthy patients to try and to be able to determine where the alterations are happening in the genes. So they're looking for ways to possibly prevent certain diseases in the future as opposed to just treating them.
As stem cell research developed, and you notice that in 1989 and 1999, they start to use embryonic. And right after that, the regulations started. My section is on regulation. And I'm going to describe the individual states' view, the national views, and the international views of regulation. Individual states started enacting their own laws to usurp the federal laws, the federal, I should say, not laws, they were executive orders from presidents. And of course, there was a mixed bag. No one state was gonna be like the other state. So what I did is I broke them down into categories. The biggest issue was over public funds to support this research. So broke down into the categories of some supported and funded it. Some supported it but didn't fund it. Some just restricted funding altogether for the embryonic stem cell, where they didn't really have a problem with the adult stem cell. Some states made it a criminal act. Others had no clear position, and there was a couple odd cases, and then there was a couple states to watch. The states to watch were Maine, New Mexico, and Washington. The odd case was Virginia. I would say, I think Illinois was one of the ones that supported it and funded it. Okay, so the U.S. regulations began with Clinton, and they tend to go along the views of individual parties. Clinton was a Democrat, and he didn't really outright outlaw the use of embryonic stem cells. He just didn't want them to generate them just for the purpose of destroying them. So he recommended that they form a National Bioethic Advisory Committee to make recommendations on the scientific, legal, ethical, religious, and public policy of stem cell research. He also went a step further to limit funds to only aborted fetuses, placentas, umbilical cord, blood, and adult stem cell research. When George Bush took office in 2000, that whole situation was reversed because he was of the Republican Party and they are of the right to life. They believe in preserving life, and then they believe that an embryo is life and that it shouldn't be destroyed. So he replaced all of Clinton's regulations, and he basically restricted any funds for new lines of stem cells from embryonic stem cells. And he gave full approval for adult stem cells because that wasn't the issue of destroying an embryo to harvest the cells. So his philosophy was there's no need for embryonic or umbilical cord or all these other stem cells research when we have adult stem cell research. That would suffice. In 2009, when Barack Obama took office, in March, he overturned all of Bush's policies and restrictions on federal funds. And basically, he told the National Institutes of Health and the Department of Health and Human Services to set up some new guidelines and policies, establish some safeguards and guidelines for responsible research of both embryonic and adult stem cell. International views vary as well. International sentiment is embryonic human stem cells versus human stem cells. There wasn't any clear-cut argument against adult stem cells on the international level. Again, just like the states, most of the states, the federal view now is that adult stem cells has always been good. But it varies from country to country, state to state. And I'm not going to go through all of these, but I just want to point out a few. Italy, Luxembourg, Portugal, they allow the creation of human embryonic stem cell procurement by law. So that's way out in left field. That's even vary from any of our state or national views. Australia, Spain, France, and Ireland prohibits the procurement of embryonic stem cells. So that's just like a reverse, total reverse from what Italy believes. And they do, by law, allow the importation of human embryonic stem cell lines, which Germany allows the procurement as well. Belgium, Denmark, France, Greece, and the Netherlands prohibit the creation of human embryos and procurement for stem cell research by law. I'm going to turn it over to Dawn. She's going to talk about the controversy.
So although stem cell research shows promise and is an exciting development in modern medicine, there still seems to be quite a lot of controversy surrounding it. Stem cell research is so controversial because of where the stem cells originate. And some of the easiest and most resourceful places to obtain stem cells would be from the tissues of aborted fetuses, from cells very early in the embryonic stage of developing life, from the umbilical cords of newborn babies, and from adult cells. Okay. So many people who oppose the idea of embryonic stem cell research argue that the value of human life applies to embryos, even though they're just like small groupings of cells that really don't have a brain or organs developed yet, but they argue for the value of life. They feel that life is a life even if it's an embryo. Okay. On the other hand, adult stem cell research is not as controversial as the other forms of stem cell research. And that's because the donor must give consent. The stem cells come from the patient's own body. In some of the research that we saw, it said that the adult stem cells are abundant. And there's always an exact DNA match, so your body's immune system won't reject them. And also, last but not least, harvesting the adult stem cells does not harm the donor. And that's pretty much important. Okay, there is some ethical controversy surrounding the allocation of government resources for stem cell research. Society needs to reshape healthcare distribution so that clinical applications of stem cell research are made available to everyone. And if this doesn't happen, then the possible benefits will only be available to those who are wealthy or to those who have better insurance. Another concern is the ethical issue of ownership of adult stem cells once they are removed. But issues of ownership can pretty much be settled using contracts before the procedure actually takes place. But what must be addressed is the possible patenting of stem cell research. It is unclear whether adult stem cells will actually be granted patents, but in the event that they do, the potential donors need to be aware of this before they sign any contracts. So it's clear that we've only begun to scratch the controversies surrounding stem cell research and the technologies that will enable these possibilities to occur. Some research using adult stem cells has already proven to be successful, like they've already mentioned, with less ethical debate regarding their use than the other forms of stem cell research. The future of stem cell research will require continuous study with more conventional approaches in order to reach its full potential. Yet, despite the many potential benefits and breakthroughs possible with stem cell research, the controversy surrounding it will likely to continue far into the future. Okay.
Okay, and that is that future that we took the various sides of the issue on. And basically, we just come back to that last statement that I made about the healthcare industry. Basically, from the readings, what we concluded was that people are afraid that the average Joe, this technology is not going to be available to them. It's only going to be available to those who have money. And as we know now, cures or medicines that help you survive diseases that may not cure you are very expensive. So, and the way pharmaceutical companies work is they get residuals. Every time you buy a prescription, they get money from that. So if they give you one shot deal that cures you, no residual, how much it's going to cost you? It's not going to be like buying a bottle of aspirin. So, back to my conclusion page. Previous. Okay. What about the general public? Will it only be available to those with insurance? And what about the celebrity factor? Celebrities have come to the forefront, especially during the Bush administration, when he cut off all research funds for research on embryonic stem cell research. They came forward saying that we needed this research, so they keep the issue in the public eye, and we know that they can afford this type of medicine. So it really came down to stem cell research is about the future. It's a cutting edge technology that brings headlines every day. So continue, so who is it going to be available to? So we'd like to ask you guys that. What do you think?
Well, I think it's going to be available to people who have money. It always comes down to that. Those who can pay, unfortunately, that's the way it works.
Should we trust the pharmaceutical companies to be the dispensers of this cure, or should we just oppose right? That's a big debate in the healthcare field today, because everybody doesn't have that cure. It seems like the few don't want the many to have it, and the many wants it, but they don't really voice their opinion, so the few is harder, more so than the many. So.
Now, if the research is funded by federal government money, so why should they sell it later on?
Because this is the way the federal government provides research. They give it to research institutions, universities, their own agencies, and then those people give it to some corporation to bring it to fruition. You don't see the government selling, what's that stuff they made the shuttle out of? The material that the shuttle's made out of is being used in other things. They developed that technology, but they can't commercialize it because the government is not for profit. So what they do is they transfer the knowledge to some public entity, some corporation, who then markets it and makes money off it. Most medical research is also supported by pharmaceutical companies and doctors, organizations and companies. So the federal government basically gives these entities the money to find out information, and then they turn around and sell it to us. So that's not the way it works. I'm sorry to say.
I have a question. You guys stated that the embryonic research has been going on since 1998, right?
Well, it was sort of, yeah, the stem lines, they started discovering the stem lines.
So, from what I understood, they've been able to make discoveries and make progress with their adult stem cells, but in your research, have you found anything, were they successful in creating any type of treatment with the embryonic? Because that seems to be one of the issues, was that they're using the embryos, but they haven't been able to do anything with them because they change so quickly, they can form cancer so easily, and they can't really manipulate them like they would like to, like they are doing with adult stem cells. So have they found anything?
Research-wise, I didn't delve really far into that, so I was looking more at the adult stem cells, but because the benefit of the adult stem cells, because it doesn't cause the tumors and there's no rejection, that's what makes the adult stem cell. If you develop a stem cell from an adult stem cell or one from an embryonic stem cell, you can make it do the same thing, but there's such a high chance of rejection or of tumors or of cancer being caused from the umbilical or from the embryonic. That's what makes the adult stem cells so superior. And of course, there's less controversy, but for me, it just seemed, we've always heard so much about the embryonic and the umbilical cord. You hardly ever hear anything about the adult stem cell. So it was very eye-opening to do this project and to find, geez, they're really the same thing. Well, actually, adult stem cells are much more superior. They're more stable. They're just getting injected back into the same patient. They can turn into numerous different types of cells. Again, initially they just injected that bone marrow right into the cardiac muscle, and the cardiac muscle regenerated.
So they haven't found anything with the embryonic then?
There certainly is research out there. It just was not part of our research.
What would be the advantages, though?
Well, what I read was like if they take those embryonic stem cells, there's a limit as to where they can put them. Say if they take them from your brain, you can't put them in your leg. But if they take them from the embryonic, they can go anywhere in the body. That's why the research is so.
Yeah, but have they been able to do anything with them, though? That's my question. I understand that they could use them for anywhere, but have they actually made a discovery where they actually come up with a cure yet? Because they've had with the adult stem cell.
Cure-wise.
No.
We're only
That's why
10 years in.
funding for the research is so important, more money they get, the more research they delve into, then they can decide, is embryonic best or is adult best? But some schools seem to think that the embryonic is best because they're more versatile. They can go.
So they find more potential with the embryonic compared to the adult.
No, the adult, it can do the exact same thing that the embryonic can do. Plus, it doesn't have the problem with the rejection or the tumors.
I guess,
Initially, they thought that the embryonic was superior. It was just recently that they found out that the adult stem cells were fluorescent. And that's what makes them so much more superior.
If you're going to work on hand, you have to take the cells from hand.
No, not for adult.
Yes.
No.
I thought that's what I read.
No, because I just said they took bone marrow and injected it into cardiac muscle, and it fixed the cardiac muscle.
Okay.
Yeah.
I was going to say that I'm pretty sure that the embryonic stem cell, now, I mean, not that I was part of their thing, but I have read some, and the embryonic cell stem research is better because it is more versatile and it lasts longer. And not to say that the adults, I mean, that's a wonderful discovery too. I think, though, that you would find different research findings on what side of the right of life question you are on. If you believe that abortion is wrong, then you're going to say, even as a scientist, that embryonic cells are bad and this, that, and the other thing, and that the adult, and then if you...
Well, I would like to say to that, in our research, we didn't look at the side of the issue of the person that we were looking at the information. We were just looking at the information. So
Yeah.
it was not a case of
No,
right
no,
to
I
life or
understand that.
not
I
in this
understand
at
that.
all.
The
So,
embryonic, you could put them in anybody. See, but the ones you get from the person, they got to go back in that person. They can't go.
I did have a question as to why there's a debate over the use of the embryonic cell stems when it comes from aborted fetuses. I mean, if I decide that I'm going to have an abortion, I'm going to decide that, and then why can't you use that life that I have thrown away to help find a cure for diabetes?
That's the
or-
controversy.
Yeah.
That's the
But I mean, why is
controversy
there-
that you're throwing
That's the
away life.
controversy.
Yeah. But it's already thrown
Controversy is
away.
that
It's
you're
like
throwing
saying,
away life.
but I've already thrown it away, so what does it matter?
Well, I think it really,
That's just my question. And-
yeah,
and
it really
it's
boils
fine.
down to moral, ethical issues when it comes to.
That's why it's so controversial, because of that.
It seems silly that if I'm allowed to abort it and it's thrown away, it's like saying that you can't recycle your garbage because I don't know.
Well, and
Another
with
side
that,
could
with
be-
that question, I think Clinton and Obama agrees with you. Bush didn't. So,
But here's where the controversy comes in. So if you're just going to abort, a pregnancy, that's fine. But will people go out and just purposely get pregnant so they can abort the fetus?
Well, only if you're going to
No,
pay them.
but that's what the controversy is.
well, that's
That's
just
what the
like,
controversy.
why would you generate them just for destruction?
Yeah, that doesn't make sense.
That was one of the points, that
That seems.
you don't want to generate just for.
well, would you agree that we leave it as open-ended thing because we cannot find a
Yeah,
conclusion to
because it's a
that?
controversy.
Are you done with your research? Okay, would you please give them a hand, thanking them for, thank you very much.